All right. So if everyone's ready, yeah. As you know, I'm Adam. And I'm from Zendesk. So I'll just be doing a introduction to functional programming, and all of it's in JavaScript, which I've heard you all doing some Node, which is convenient. So yep, that's me, and there's my Twitter handle. I work on a product called Connect, which recently launched, and if you're into watching like product videos, you can go to the Zendesk website and look that up. But yeah, it's not terribly exciting.
Is that the Dell was working on?
Yeah, we work on the same team.
Oh, really?
Yeah.
Nice.
So what we'll be going over is like the idea, like what fundamental ideas are in functional programming, like the basic ideas of what functional programming is, what it means to treat functions as first-class citizens, and what functional purity is, and also currying and partial application. So before we get into it, I didn't know if ES6 was if it's a thing that everyone's been over. So I just figured I'd do like a little quick primer of the syntax I'll be using. If you're not familiar with it, there's fat arrow functions, which just gets rid of the function keyword. And so at the top, we just have a fat arrow function that it's a function that adds stuff, and we have an implicit return as well. And then below that, we have another fat arrow function, but this time we're using braces, and it doesn't have the implicit return, so we have to use the return keyword. And then on the 7th and 8th line, we're using a feature called deconstructing, I think it's called in JavaScript. And it's called pattern matching in other languages, but get name, you just pass an object into there, and it plucks the name property off of that object. And then that function just returns the name property, whatever it may be. And then the head function down there, that deconstructs an array. So it grabs the first element in the array, and then the dot 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 is kind of like a splat, like just the rest of it, whatever it is. So that'll be like the tail end of the array, and head will just be the first element. Does that make sense? Sweet. So functional programming. So the most difficult question to answer is like, what is functional programming? Because I feel like when you get introduced to OO, it's very clear that OO was made by programmers for programmers. Everything is pretty well laid out. Everything has a very specific name. Everything is in its place. But functional programming, for better or for worse, was dreamed up by people with crazy hair and lab coats in MIT, and they know some crazy math theory as well. And you often get functional programming kind of complected with the math theory. So if you're looking up how to do currying, you get some crazy math notation. Like, oh, cool, I know how to do currying in math, but I want to know how to do currying in programming. So don't get discouraged. Like, that's the last time I'm going to mention math today. And like, I once got half a point on a math test out of like 20, so I'm really bad at math, so don't get discouraged. So I guess like the core aspects of functional programming are, not surprisingly, functions, and your data models, and then what those functions do to those data models, and that's all of functional programming. There's no other constructs that you need to do it. There's nothing like classes or interfaces or anything like that. It's just functions in your data, and then what those functions do to your data. So we'll be going over what it means to treat functions as first-class citizens. And if you're doing a lot of Node, you already be familiar with some of these practices. Because in Node, you often pass in a callback as a parameter, and if you're doing that, you're already doing functional programming. So to treat functions as first-class citizens, you should be able to assign functions to variables, which you saw in the example before. You should also be able to pass functions as parameters, such as like callbacks. And you should also be able to return functions as return values. So this is kind of like a kitchen sink example of what it means to treat functions as first-class citizens. So on the first line, we have just a function named identity. Like, the name isn't important, but what it's doing is important, because it's using that fat arrow syntax, and it just takes a value, and then it returns a function that returns that original value. why it's there and what it's doing isn't why it's there isn't important, but what it's doing in terms of returning a function, that's quite important, because you find that pattern quite often in functional programming, that you can kind of prime the cache of arguments that you want with a particular function, or you want this thing to act in a certain way, and it returns a function that acts in that certain way. You can think of it as like a factory for functions. And we can return functions that take more parameters. So we have that compose function that takes 2 parameters, and those happen to be functions as well. Then it returns another function, and it just takes any number of arguments, and it just calls the first function, and it passes that output to the last function. So that's treating functions as first-class citizens in the sense that it's taking them as parameters, but it's also returning a function. So the idea of returning functions, taking them as parameters, is very common. And if you start going knee-deep into functional programming, you're going to get very intimate with the idea of returning functions and passing them around, and remembering that this value is a function here and there. So if you're a bit uncertain of functions, then a very good way to get comfortable with them is to start writing your own functions like this that return things and do all that sort of stuff that we'll be doing in today's talk. Treating functions as first-class citizens is like an umbrella term for a lot of design patterns in functional programming, and one of the design patterns is higher-order functions, and that's just a really fancy term for other functions that take functions as parameters. So the most popular of which are map, filter, and reduce. So thankfully they already exist in JavaScript, and they exist on the array prototype. If you haven't used them before, filter does exactly what it sounds like it does. It filters the array. So the basics of how it works is that you provide a function as a parameter, and then that function will get applied to every element in the array. So if I have an array of numbers and I only want the even ones out, I can use modulus on that number, and then so what's happening is that on the first iteration we get 1, and so 1 modulus 2 is a falsy value. So that tells filter, hey, I don't want this value in the resulting array. And then when it gets to 2, it's a truthy value, and it says, I do want that value in the resulting array, and we end up with an array of just 2. And conversely, if we flip the Boolean value just with a bang, we end up with an array of odd numbers. Does that make sense how that works? Cool. So going forward from that, before I talk about map, like just airing my own opinion about functional programming, like I love functional programming, but I think everything in functional programming is named really, really badly. And it's a big barrier of entry of getting into functional programming, because like if you're talking about like monads and monoids and like comonads and stuff, like that's not descriptive of what the problem is, and it's a bit stupid. That's like all math theory jargon that's carried over from like the labs of MIT. But so like the word map really doesn't make any sense until you drink the Kool-Aid and learn what map does. So like I'll ignore like what map is, and we'll just look at the example. So map is also a higher order function, and it, instead of filtering out the contents of the array, the idea is that you're mapping the contents of the array to some other form. So if we have an array of numbers and we double all those, we end up with a new array. So it's the same shape, it's the same data structure, but the contents is new. So we're mapping the old stuff to the new stuff. That's the idea. I think it'd be named better. I don't know what the name would be, but so yeah, it works just like filters, that it takes a function as a parameter, and if it's dependent on it, you also happen to get the index of the array that you're up to as a second parameter. But that sometimes people in the functional programming community get a bit uppity about that, because like, no, map is only supposed to take a function as a parameter, but sometimes there's secret clubs that are so secret that nobody joins them, and so, you know. And the last example that we have is reduce, which is also another popular higher order function, but it's probably the one that's the most black magic. The first time I looked at it, it was very black magic, and I had to spend a lot of time on Stack Overflow and all that sort of stuff. So what's happening is that we pass in a function here, and so that function takes two parameters, so n being the number, 1, 2, or 3, and then a total. And this total comes from here. So that second parameter there, that's like an initial value or a default value. So what happens on the first iteration of reduce is that this 0 will be sent into this function. So we'll get 1 here, and then we'll get 0 here. So in the first iteration, it will be 0 plus 1, which is 1, and then 1 will be returned. And so reduce will keep that for us. And then on the second iteration, we'll get the second number in the array, which will be 2. And then the total here will be the previous return value of while we're looping through the array. So in that case, it'll be 1. So then 1 plus 2 is 3. The next iteration, 3 plus 3 is 6. So the idea with map, filter, and reduce is that they're often used in conjunction when you have a collection of some data structures. So like if you imagine that you have a collection of users, or even you have a collection of user IDs, and you want to map those to actual user objects or user maps or whatever you're representing your users as. So you go and fetch those users, and now you have an array of user objects. But I only want the administrators, so you filter that somehow and only get the administrators. And then maybe you want to reduce that down to a single value, such as like maybe these administrators represent a group or something like that. So you can kind of squash them all together with some logic, and you end up with a single thing at the end. So the idea, I like cooking, so I think of reducing as like you stick whatever in a pot and you get like kind of like a reduced value of it down till you get the one thing that's really potent. So the next area of treating functions as first-class citizens is function composition, and that's just a fancy way of saying it's just chaining functions up and calling them all at once. So it's just taking like really small functions and making a bigger function, and that's kind of like one of the key aspects of functional programming. So I have 3 examples here, and on the top it's a rather boring example. It's how you do this thing without functional composition. So all I'm doing is I'm calling getName, and I'm passing an object with a name property. And as you'd assume, that just gets the name off of that object. And then I'm printing that name out, so it'd say, Adam or something like that. And on the second example, that's function composition. Like that's all that is that you're calling one function, and so the output of one function is being sent into another function. So if I call getName, it'll pluck the name off that object, and that output would be sent into printName. It'll then print the name. So the first 2 examples there, they're logically the same. They present the output is the same thing. However, the idea of functional composition is the idea of taking these very tiny functions and creating larger things from them. You'll often find in functional programming languages that you have like a module or something that has a bunch of functions that work on maps or strings or something, and they all live there. And they all do like very individual tiny things, but then when you combine them together, you can strip out white space, and like you can split on certain things. You can do really complex logic, but in of themselves they're actually like quite stupid functions. And then lastly, on the third example, I'm using Ramda, which is just like it's like Lodash or underscore. It's just a library with a bunch of helper functions in it, and one of which happens to be compose. And so traditionally, function composition goes from right to left, and for people that read left to right, that can be like, what the fuck is happening? Like, because you're reading like all of your programming is like left to right, and then all of a sudden you're like, oh no shit, I need to read right to left. And like again, you need to drink the Kool-Aid to understand why. And the reason being is that like traditionally, like when you compose functions together, like in the second example, the code execution is right to left because getName is executing before printName, and so the compose function is supposed to mimic that. I don't know. I like reading it from left to right. So there are different ways you can make this go left to right, but traditionally it's right to left. So compose is a higher order function, just like map, filter, and reduce, and it takes functions as parameters. So the first function we want to execute is getName, right? So we put that all the way on the right side. The second function we want to execute is print name, so we put that at the end, and we don't want to execute anything after that. So we pass those into compose, and what compose does, it returns a function, and we're storing that in the const there. So now we have this bigger function made out of these smaller functions. Then when we call get and print name, I can just pass in that object with the name property, and it'll pluck that name off. It'll send that into print name, and then it'll ultimately print to the console or something like that. But the idea of taking these small, very tiny functions and composing them together is very central to the idea of functional programming. You'll find that you shoot yourself in the foot far less often if you have like this big problem, and so you start working on it and you take like a very small portion of that. Like if you have a user object and you want to get all of its permissions in the system, like it can only view certain things or whatever have you, or you want to split its name into, like if you take those like very small problems out of your big problem and make functions that only handle those very small things, and then you build those up to do the big thing. Cool. So moving on from treating functions as first-class citizens, we're going to look at functional purity, which is arguably one of the most difficult parts of functional programming, but also one of the most beneficial. And it's the part that still like keeps me up at night when I'm thinking about it and how I want to do it in JavaScript. But you'll see why in a bit. But functional purity is taking functions and ensuring that ensuring that if I give them the same input, they'll always give me the same output. So if I have a function that adds two things together, if I pass it 1 and 2, I always expect it to give me 3. If it suddenly started giving me 6 and 12 and stuff like that, it's no longer reliable, and your whole program will crash. Like, that's not good. It's the exact opposite of what you want. So on the left and right, there's two examples, and on the left is a impure function, and on the right is a pure function. And there's not much difference between the two. The difference is very subtle, but the implications of the difference are quite big. So on the left, like we have this arbitrary users collection, and so we map through those, and we just pluck the name off of every single one. So we end up with an array of names, and now I want just to print all those names to the console. So on the left, you can see that for each name, I just call console.log, and then I print the name out. Cool, whatever. But if you take a closer look, you can see that print all names has a dependency on the names array, which exists outside of it. So it doesn't have any control over that array. And what happens if we call print all names and our program continues on, whatever, and then we have to print all the names again, but the names have changed, and we expect it to be in one state, but it's really not. And so instead of just having a dependency on some like function argument or function parameter, we now have a dependency on our entire program being in some state. And if you go to test something and you have to orchestrate all this state into a certain form to make your program work, that's going to be really tiresome really quickly, because as soon as a user calls you, like, hey, this thing doesn't work, and you ask them how they did it, and they did some really obscure, like, I clicked here, and then I moved the keyboard, and then I did this other thing, and and then you have to replicate all that, and it still doesn't work. It could be because your functions have dependencies on some wider global state, and global state is usually the root of all evil. So on the right side, we have the pure version of it, and the only difference is that we're taking names as a function parameter, and that's a very small change for such like a big implication on your entire system. So our print all names function no longer has this dependency on this global state. So we no longer have to orchestrate this names array into a certain form to make this work. We can just call print all names with an empty array, or an array of names, or it could be one name or 100 names. It doesn't matter. If I pass it 100 names, it'll always print the same 100 names out. It's very predictable, and it won't keep you up at night. So the reason why that's such an important thing is imagine if you had like a function that calls an API. It uses Ajax, it uses fetch, whatever you happen to be using, and if it had some dependency on like an HTTP module, what happens if you want to change that HTTP module? If you change from using normal Ajax to fetch, or you using some other sort of thing, instead of having that dependency on some global state, like grabbing that out of the global ether that is JavaScript, if you pass that in, you can just swap it out. Like, what if you want to test it and you provide a mock one that just has like method stubs on it? That's fine. It doesn't care as long as you pass in the thing that kind of looks like the thing it's expecting. That's fine. Instead of having it exist in your module system, you can just pass it in and it doesn't have to worry about it. Cool. So next in our final section, I guess we'll be touching on a slightly more complex part of functional programming, and I guess it's not so much complex as it took me a while to wrap my head around it. I had to do quite a lot of Googling or quite a lot of Stack Overflowing to like understand exactly where the line was between currying and partial application. I'll touch on like where the line is, but it can often if I don't think about it for quite a long time, I just forget about it. I'm like, oh, the same thing, whatever. But cue me like 3 days ago and looking at the definition again for this talk. So first we'll touch on partial application because it's kind of like the parent to currying. So in the functional world, to call a function, the fancy way to say it is to apply it. And you'll find that the function prototype in JavaScript actually has a method or a function called apply. So like if you hear someone say, oh, I applied this function to this data model, they're just saying like I called that function with that data as a parameter. So partial application really means that we're halfway calling, like we're still calling it, but we're saying like, hey, use these parameters, but don't execute yet, is what we're saying. So thankfully that's available in the bind function, which is on the function prototype in JavaScript. So if I have our very trusty add method there, which does exactly what you think it would do, if I call bind on it, it takes a couple of parameters, the first one being the this context that the function operates in. And are we all familiar with like the this keyword in JavaScript and how crazy it is? If you're not, then I suggest don't look at it. So passing in null just says like, I don't care what context it is, just whatever you expect it to be, let it be. But then everything after that first parameter are the parameters that I want to pass to that function when it executes. So what that's really doing is it kind of caches those arguments so that when the function does execute, it gets those arguments. So the point of it is if you have an event handler for like an input or a button or something like that. So imagine that you have like your input is updating some state or something like an object or something like that. So instead of passing in just like an inline function to input on click, you can do .bind and pass in that state, and then that will turn a function to the onChange handler, and then you don't need to worry about passing an inline function. You can have like this concrete example of like, this is the function I want to call with these parameters, call .bind, and then it'll do it for you. You'll find that when you start doing, if you already haven't started doing React, that it's a quite common pattern to define some functions and then to use bind to pass it in for like an onChange on click or whatever it might be. So after you call .bind and you get the function back, you can call that function again, and any parameters that you provide to the second calling of that function get provided to the original function. So you can see here that I've only provided one of the parameters, being the number 1, and then the second time I call it, I provide 2, but I get 3 out. So any of the parameters that I provide after the this context and any parameters I provide in the second calling get sent to that function. So in the case of the input, I can provide the, like if it's a comment box or something like that, I can provide the place where all the comments are stored, and then in the second one, it gets provided the event. And so I can get like event.target.text or name or whatever I'm having to get off the event. So the big brother to partial application is currying. I think the dude that came up with it, his last name was Curry. I don't know. I'm not entirely sure. But so again, I'm using Ramda to give me this function. And so curry is a higher order function that takes any number of parameters as long as they're functions. So again, I have the add method there, and I call curry and I pass in add, and so I get another function back. And what that lets me do is something very, very similar to partial application, but partial application has no context about how many parameters our function takes. So if I go back, if our add method had 36 function parameters or something like that, partial application and bind have no idea about that. It just lets me call bind once, and then I call that function again, and that's it. It executes. Whereas currying, on the other hand, if I curry a function, the curried function knows how many parameters it expects. So if I had an add method with 36 different parameters, I would either have to call that function with the 36 parameters up front, or I could call it with 34 or 32, and then it would keep returning a function until all the parameters are available. Then it would execute. So similar to like an input box or something like that, if you had several places where you're storing that state, and they're kind of like scattered around your system, you don't want to have like this central module where you like require those in and pass it in and like do this all like jiggery pokery with like orchestrating state. You could instead like pass one state store in, then return that function, carry it around for a little bit, pass another state store in, okay, and then the last parameter would be like the event or something like that. And so you just assign that function to the onChange handler, onClick, whatever it may be. And then when a curried function receives its final parameter, then it'll execute. And so this serves the same use case as partial application. It's just a much nicer way to go about it instead of calling things like bind or apply, and which exist in most functional languages. You'll often find that in a lot of functional languages such as F# or Haskell, a lot of other functional languages, that all functions, no matter what, are curried. It's just a property of the language. And you don't, actually in Haskell, there's no such thing as a function that takes multiple parameters. There's just functions that take one parameter and return functions, but that's kind of like hidden from the thing. So currying is a very normal thing, and like it took me a while to get comfortable with it. I was like, oh, like how long do I go like with these braces or whatever, but once you do it and kind of fiddle around with it and play with it for a little while, it becomes very familiar. And that's what I think is great about functional programming, is that once you get over like the math jargon and like the shock of reading math notation, like if you ignore that, it's actually very easy to get into, and it's very easy to start playing with. So bringing all of that together, I'll show you an example of some non-functional code, and then we'll refactor it to functional. So if I had a function just called big add, which is obviously very core to a very important business value, like this is enterprise grade stuff. So if I take an array and I just add all those numbers together and then I return the total, just like the function from before, this has a dependency on something outside of it. And I think a really good like rule of thumb when you're looking at functions, that if you see for each, or if you see it referencing something outside of its own curly braces, it's impure. Because for each, if you call for each, you can't return anything out of it. It just does something. Whereas map, filter, and reduce, you can return something and you get something back out of it. So if I tried to chain off of for each, there'd be undefined. There's nothing there. or as map, filter, and reduce, something gets returned, so I can keep calling methods off of it. So it's a good rule of thumb. Like, there are legitimate uses for each. Like, there are cases where you just want to like impurely change something. Like if you're often if you're like starting up your app and like your main function or whatever it may be, you often use for each there, or in other places where you just want to like, it doesn't really matter to be pure or impure. But in this example, we're just taking this array and we have this dependency outside of it. So if I was going to go like whole hog, functional, and refactor this, there's quite a number of things I can do. Like I said, like we have this big picture of like adding an array of numbers together. Like the small picture is just adding numbers together. So the easiest thing to do would just make an add function and kind of extract that out, right? And then we're also, instead of making an add function, like how do I add an array of functions together? It's really taking like a bunch of things and then reducing it down to one value. You're kind of like sticking it in the pot and steaming it for a while and getting this one value out. So that's an indication like, oh, I can use reduce. I can maybe use currying, maybe. I could kind of make it very generic. So if we go like, if we drink the Kool-Aid and take a big add and make it functional and put it all into these little tiny blocks, this is, if you want to be like really excessive about it, this is what you end up with. So first off, I'm using Lambda again, and then I make my add function, which is just takes two things, adds them together, and then I'm making a reduce function. So we know that the array prototype has reduce on it, so that we know that we can pass in any array and we call it reduce. That's fine. That's we can use that bit of polymorphism there because everything that's an array has reduce. So I make this very generic function that takes an array, a function, and then like an initial value or a default value. And then I just call reduce with that stuff. Now I'm also making a function that takes any number of arguments and then turns that into an array. So it's using that kind of like splat or rest syntax from ES6. Then I'm composing that all together. And the one bit of syntax that's there that we haven't gone over is the double underscore, or in the functional world it's called like a hole. So what that means is that often in programming languages where everything's curried by default, you can often provide holes to the curried function, so that like if I have a curry function that takes 3 parameters, but I only have parameters 2 and 3, I can provide a hole in the first parameter, and it will return a function that takes the first parameter. So you can shuffle parameters around like that depending on when they come in. So that's quite useful if you have like an architecture that's evented, or you have something that's concurrent. So if you have these things that are concurrent running on different threads, what if thread 2 finishes before thread 1 and thread 3 finishes last, or what have you, and it comes in different orders every time you run it? Like, then you can't predict what parameter is going to go where. So as long as you can provide these holes in the certain spaces, it's okay. It'll return a function that takes that parameter. So going back to our example, we're taking that reduce function, and so we can see that the first parameter is an array, and we don't have that array yet. We're just making a function that adds all these numbers together, so we provide a hole. We don't have it. But we do know that the function we want to run on that array is adding everything together. So we've broken that big problem down into a small one, and we know that the initial value that we want to provide it is 0. And we also know that we want to be able to provide it with lots of numbers, like an unbounded number of numbers. Bad way to say that. So if we use that to array, we know that that's the first one we want to call. We want to be able to pass it any number of numbers and turn that into an array, and then we'll call reduce on that. So that's what we're doing there. We're composing two array together with a curried, or partially applied, I should say, version of reduce. Then what we're getting back is a function that takes one parameter, any number of parameters, which is the numbers, turns that into an array, calls add on it, and then we get the result back. Does that make sense? So while this is like going deep into it, I actually have, like, when I want to learn something, no matter what it is, I always try to, even if there's like a really popular library like React or whatever it is, I always try to re-implement it just for myself. Like, I don't put it on NPM or something like that. I just re-implement it. And so I wanted to learn more about functional composition, and so I was like, okay, Lodash and Ramda can do it, so I'll try and do it on my own first and maybe look at their source or whatever. And so I made a library that did functional composition, and on the left is my first attempt at it, which, like, I'm sure if my employer saw that code prior to hiring me, I wouldn't be working there because it's really, really bad. But in the new version, which is slightly better, but it's like going whole hog on the functional idea of breaking everything down into small parts and using currying and partial application and everything. So I'll horrify you with the old code first. No.
You can try that Wi-Fi up there.
Okay. Actually, I'll just hotspot off my phone. It'll connect automatically. If you don't look at the man behind the mirror, or behind the curtain.
Has anyone tried any functional programming before? Oh, Ian, you'd done
Haskell.
Yeah.
Oh shit.
Yeah,
okay.
yeah.
No, that was a long time ago.
Okay. Yeah, I've tried to learn Haskell a couple times, but every time I get into it, I get like 2 tutorials and I'm like, so I'll go down to like the part that's like the main, where all the main logic is. So like the idea is that I want to be able to compose from either left to right or right to left. Like that's a normal use case in Lodash and Ramda. So I want to be able to do the same thing. Okay, so this is before I knew about the splat parameters. And is anyone familiar with the arguments array that all functions get? It's probably for the better, because it's how you get all the arguments that a function is provided. That's how you did it before there were the rest or splat syntax in ES6. And it's an array-like object. Like it doesn't have map and reduce. It's actually like an object that has a property of 0, and it's a thing. So first off, I start by getting all of the outer arguments, which are all the functions that you're passing to this compose thing. So I want to compose, toArray and add together, for example. That's what you pass it the first time you call this thing. Then the second time you call it is when you actually want to execute the composing. So you're actually gonna run toArray and then add function, for example. And so I do this weird thing where I like cache the arguments, and then I make an inline loop function where like there's an if statement, and you can see like a rule of thumb. There's a for each, so some impure stuff's happening in here. And you can see I'm referencing this value. I've been referencing this value function, or not value there, out here, and it's like all intertwined, and there's all sorts of like dependencies. And I can assure you there were no unit tests for this, because that'd be.
So this is sporadic order, the way this accepts multiple arguments, right? Whereas the one that you showed before just had 2. So that's sort of like it's a bit more expansive than that one that you showed before.
Yes, yeah. So you can pass in any number of functions to this function. And then it'll smush all those together and make a bigger function. So looking at this and coming down to like the final masterpiece, which is this horrible for each function, it looks at the direction you give it, and then there's some additional logic to be like, oh, I want to go through an array normally, just left to right, or I want to go through a reverse with it, which is like traditional composition, which is right to left. And so there's that logic in there as well, which, like, it's 2016, dude. Like, if the computer doesn't know how to reverse a list, goddamn. Like, so, going back to the new, the refactoring of it, like,
Whoa.
so,
Wow.
yeah. So we've taken, I don't know, like 40 lines of like imperative typical programming, and kind of like taking a deep breath, like a sip of water, and like thought about how to put together with functional principles. And we have like 8 lines of actual code, maybe 7. So what this does is, first off, you call this you call this compose function, and you give it a direction. Like I want to go from right to left, or I want to go left to right. And so based on that direction, it'll do several. It'll be one of two things. So it takes what I decided to call an implementation, which is just a function, and then returns another function which takes any number of functions, so it's unbounded, and that finally returns one more function that takes the arguments for those functions you passed in previously, and it just calls the implementation. So here that's currying. That's just like a manual version of currying. So you'll, in JavaScript at least, or in Pascal where everything's curried, you don't really need to worry about it. But in JavaScript, you need to have the forethought of like, do I want this to be curried or not, or can I just achieve this with like a manual style curry? Like, this is food for thought while you're putting things together. So I call this compose factory with our implementation, which is here. So it takes the functions which are provided there, and it takes the arguments to those functions which come from there, and we know that funcs is an array because we're using the splat syntax here, and we know that all arrays have reduce, and really what functional composition is reducing all of these, like a lot of these values down to like one value, which is one function. So we reduce those all together, and we pass in the function we want to run on all those values, and we pass in the initial value here. So execute is just this function here. It takes a value, and it takes the initial value, which happens to be a function. So if it's an array, we provide it to the function as separate parameters. And if it's not an array, we just call it with the value. And conversely, if you want to do composition from right to left, we just call reverse on the array. Like, we don't need any complicated for each, nothing like that. With functional programming, like I said before, you're taking like this bigger problem, which is I want to compose functions together from right to left, which isn't how lists works. Okay, so I need to go in reverse, and so I start doing that. Like, just hide that away in a function, abstract it, so that like the next person that comes along, or like future you, doesn't have to think about that implementation or think about those details. And thankfully, the array prototype already has reverse on it. And then we just do the same thing. We treat it exactly the same as the other ones, and like that's it. It's like I said at the start of the talk, functional programming is all about functions and your data, and whatever the data happens to be, and how you apply your functions to your data. So in this case, our data is functions, because in JavaScript they're just objects that have things on them. And what we want to do to it is call those functions in a certain order. We want to chain them up for later execution. So I guess what we've gone through is treating functions as first-class citizens, and what that means as like an umbrella term. Means that we can pass around functions as parameters, means we can store them as values, it means that we can treat them just like any other data that's in our program, like numbers or strings or maps or whatever it may be. We've also gone over functional composition, which is the act of taking a lot of functions and kind of smushing them together and making one big function that we can call later. We've also gone over functional purity, which is the idea of taking your dependencies as parameters and making sure that your function always gives the same output given the same input. And we've also gone over currying partial application, which is delaying your functions to a certain point until they have all of their arguments, or until all of their dependencies are known. And I guess like there may be, like when you're doing Ruby or whatever, like Ruby makes it really awkward to do functional programming, because like the idea of like a method and a lambda are different. And like if you Google like Ruby proc, there's like hundreds of forums of people arguing about like procs, and it's a whole thing. But like it's awkward to do functional programming in there, but you can still do it in some cases. Like embrace of Ruby, but approach it with like a functional programming lens. Or if you're in JavaScript, like you can do functional programming. JavaScript is really welcoming to functional programming. So like if you want to, like drink the Kool-Aid, like jump in and give it a shot. The ecosystem is super rich. Like there's Lodash, and then like as a sister library to that, there's functional Lodash, which everything's curried, and it's much more welcoming to like the idea of like chaining everything together. There's also Ramda, and a really good resource that kind of like really broke away from the math bullshittery of functional programming is a book that I read. It's Dr. Boolean's Guide to Functional Programming in JavaScript, and like it's just plain English functional programming. It's really nice, and like the biggest thing for functional programming for me is the fact that pure functions are really cool and they make testing really easy. Sorry. So like if you have something that depends on HTTP, like you don't want to have to do network calls, like just passing them off, or you don't want to have to update this state store, update that state store, and all that sort of idea. I think pure functions are like, if someone asked me like, why do you do functional programming, I'd be like, pure functions, done. But the cons of it is that if you're working on a team, if you just join a team or you think about you want to use functional programming concepts, like you have to get team buy-in if you're going to go like whole hog on it. You have to everyone has to be like, okay, we'll give this a go. You can't just like go in and start like changing everybody's code and like doing that whole thing. And a lot of the terminology and a lot of the ideas are gated behind like horrible domain knowledge and terrible naming, and it's really intimidating. Like when you're googling like, oh, I just want like, what's the functional programming idea of like adding two numbers together, and you're like, oh, it's a monoid. What? No. Like so that's like, don't get intimidated. If you see something, like just keep asking questions until it makes sense. That's what I've done for my entire career, and I've never been fired for asking questions. So cool. So that's it. I'm Adam, and all the slides and all the code and the recording for this will be up at that GitHub URL there. So, and like I'm on Twitter. If you have like, I really like talking about functional programming. If you can't gather by me going somewhere and just giving a talk about it. So like if you ever have any questions or anything like that, just ask.
So I'll ask for you to email me that as well, actually, because I'll send it.
Yeah, for sure. Cool.
Well, thanks, Guy. Thanks, Adam. So I'm just cautious of the time as well, but is that okay to take a couple of questions?
Yeah, of course, yeah.
So what sort of stuff do you do day to day, and how much of this functional programming stuff can you use? And what do you do, like?
Yeah, so I like day to day. I do Rails, Ruby, and I do JavaScript, and it's all React and Redux. And the JavaScript side of things is really welcoming to functional programming. Whereas like when I have to do the Rails side of it, which like my personal opinion, thankfully, isn't that often. There's other people on the team that do that sort of stuff. I embrace the O of it. Yeah. But in the Redux side of things, it's very welcoming because the whole idea of Redux is very functional in of itself, and React is very welcoming to like currying and partial application and everything.
How long have you been with Zendesk?
Sorry?
How long have you been with Zendesk?
A year, maybe like a year and a half, I think. Yeah.
What are you about for that?
A small financial company in Hawthorne. So we were like a competitor to Zero, that type of thing. Yeah. And I was the only one on the JavaScript team there, so I could do as much functional programming as I want. But yeah.
Have you been tempted by Elm or anything like that?
Yeah. Does anyone know what Elm is? Yeah. Okay. Sweet. So yeah, if you're not, it's a Haskell-like language, but it compiles down to JavaScript, and so you get all the niceties of Haskell-like type classes and stuff like that. But yeah, I've definitely been tempted, and there's a couple of us on our team that are really into functional programming, and we've tried it every once in a while, but we've found that if we want to do it, we either have to have like a new project that we want to try it on, or we have to like find a way to like shoehorn it into a React project and then like go from there. But yeah, it's really tempting.
Any more questions, guys? Good time.
Cool.
What was the hardest part that you found just learning it?
Getting over the math.
Okay.
Because I'm terrible at math. I failed every math class that I had in school, absolutely every single one. And when I went to college in the U.S. for like a year or whatever, I had to take classes in the summer to catch up on math. So I'm terrible at math. And getting over the fact that like if you like Wikipedia like lambda calculus, which is like a thing in functional programming, like you get the dude that made lambda calculus, and you get all these like different notations for like hurried functions and stuff. I'm like, dude, no, just tell me like what. Just tell me. Like I don't want to have to deal with learning. I don't want to have to deal with learning category theory because I want to learn what monads are. Like I want to know what they look like in JavaScript. That's the hardest part. And nowadays because functional programming is becoming like a popular thing in JavaScript. There's a few resources where they're kind of stripping away the like math, the MIT garbage of it, and it's just programming, which is nice. But yeah, it's still getting there.
What's your education look like so far? Like in terms of, did you study programming? Did you study comp sci?
Yeah, not at all. No. So I did a year of college in the U.S., which is, if you can't tell, that's where I'm from. And that wasn't for me, and so I came back over here and I started doing a network design and security degree at Swinburne, which is all about like configuring Cisco routers and Juniper routers and all that sort of stuff. And I had a total of, I think it might have been 3 actual classes on programming. It was Introduction to Programming with C, Introduction to Programming with Java, and Introduction to Programming with PHP. That's it. And the rest of it was like on like Scrum and like project management and stuff like that. And then I did my like CCNA, CCNP. So like halfway through, like I find that I do my best thinking like on the train. So I was like listening to music, remember like one of those like fucked up songs like from like Celine Dion or something, kind of like, what am I doing with my life? And so that's when I decided I was like, okay, I'll finish my degree. I've already sunk so much money into it, but I'll also learn programming, and then so that's where I am now.
So you're self-taught since then, are you?
Yeah, totally. Yeah, I learned. At my last job, we didn't use React or anything. We used Angular, and then we used React after that. And so I just learned. Or sorry, not React. Knockout is what we used, which is another front-end library. I just learned React in my spare time and stuff like that. And thankfully, then I didn't have a kid, so I had plenty of time to do it. But yeah.
So you didn't learn vanilla JavaScript before learning React, or?
Yeah. I don't know. I came into I think I came into JavaScript at like a weird stage because like I came in like when Angular was like becoming popular and jQuery was like not the cool thing to use. So like I learned jQuery so I didn't have to learn vanilla JavaScript, and then I just went to Angular and I was able to skate into Zendesk on React. And so like when I do have to touch vanilla JavaScript, like when no one's looking, I just like Google something real quick, and and so thankfully I use mostly React, but like I'm picking up vanilla JavaScript when I have to. Like I'm very comfortable in JavaScript as like a programming language, but when you ask me to interact with just the DOM, I start Googling stuff very quickly. Yeah.
Sorry, I'll have you guys and stuff, but I think that's it for Adam.
Cool.
Appreciate it. Yeah, cheers.